Hello, I'm Eric Macias, Embedded RF Applications Engineer, and I'm here to talk to you today about the introduction of a complete NFC solution Texas Instruments has developed with a third party, which can be used for promoting the TRF7970A and TI microcontrollers in applications which are requiring full NFC support. This means reader-writer, card emulation, and peer-to-peer, operating in a mode switching format or individually. Today we will cover the NFC Link overview, NFC Stack plus evaluation overview, the NFC Link beta release components, software and hardware roadmap, NFC Link demo out-of-box experience, describing the hardware and software configurations. Furthermore, we will cover the NFC Link file structure and the porting process to other MSP430s. NFC Link is the market name for a TI-based hardware, firmware library, and software stack solution for near-field communications. Integrations of NFC into end equipment is growing rapidly and spanning across consumer, medical, retail, industrial, automotive, and smart grid application spaces. This solution is a modular platform, firmware and hardware, designed to not only make it easier for the field to promote the TRF7970A and TI microcontrollers in these mentioned areas, but also serve as a powerful development tool for customers to use immediately for integration into their product. The NFC host is an easy-to-use GUI running on a Windows PC to enable or disable the TRS7970's operating mode. It currently communicates with the NFC controller over USB. The NFC Stack is currently running on Windows 6.5, Windows 7, and Windows 8. The NFC controller is embedded inside the CCS project, including API stack examples for all three modes of NFC operations. The hardware required to demonstrate the capabilities of the solution consists of the MSP430 F5529 experimenters board running the CCS project, a TRF7970 ATB, and a USB cable. The reference design will be able to communicate with other TRF7970s, static or dynamic tags, and NFC-enabled devices. The simplified block diagram of the NFC Link architecture is shown here, where the NFC host could be an A8 or A9, ARM, or other microprocessors. The NFC controller running an embedded MCU could be ARM, MSP430, or other microcontrollers. The TRF7970 is the NFC transceiver, capable of communicating with passive tags, NFC-enabled speakers, handsets, or tablets. The NFC Stack evaluation application demonstrates the functionality of the NFC Stack, which handles the higher layers of all three NFC operating modes after the anti-collision process is completed. It has been developed based on the NFC Controller Interface, NCI protocol, from the NFC forum to communicate with the NFC controller, enabling or disabling the NFC operating modes. There are 4 tag platform types supported, including Type 2, Type 3, Type 4, A or B, and Type 5. As I mentioned earlier, the current functionality of the NFC Stack is implemented as a Windows GUI. However, for an actual application, there are other options. It can be compiled as a driver component into the operating system, or it can be compiled into an NFC module where the NFC controller and NFC host are both on a dedicated CPU running full or parts of the protocol stack. It can also be compiled to run as a graphical user interface running on different operating systems, including Windows. In the June 18th update, we have released a Windows GUI installer for the NFC Stack evaluation application, a pre-compiled NFC Link library used by developers to port to other MSP430s, 2 CCS projects supporting all 3 NFC operating modes. One of the projects uses the USB stack to communicate with the host. The other uses the UART interface, requiring a UART to USB bridge to run the demo on a PC. The software and hardware roadmap, as shown, include the integration into MSP430ware, support for the IAR IDE, support for other TI microcontroller families, including the Cortex-M4, Cortex-A8, TMS-470 or 570, also known as Hercules, and other automotive qualified microcontrollers. We will be releasing Android, Linux, and QNX support for the NFC host. Furthermore, we will be adding support for MIFARE DeskFire EV1 Plus and Classic, as well as NFC Tag Type 1. We will be releasing quarterly updates with MSP430ware. For the first time, we will be releasing our TI NFC RFID Android application. With the upcoming release of the MSP430 F5529 Launchpad, we will be releasing a TRF7970A booster pack. The next set of slides will introduce and explain the steps needed to use a demo effectively. Use the NFC Link installer executable to get the firmware code project and the NFC player GUI loaded onto a PC. Double-click the installer and follow the instructions. Then the NFC player GUI will begin installation automatically. When completed, just press the close button and plug the hardware into the USB port on the PC. Here, we have the hardware needed for the demo. On the top left, we have the TRS7970 ATB module, which plugs into the EM headers on the MSP430 F5529 experimenters board. The blue jumper needs to be connected between ports 2.0 and 4.0 on the board to use the interruptible GPIO feature on port 2.0. Make sure the power switch on the left side of the board is in the LDO position. When the hardware has the correct firmware downloaded and is connected via USB, the Harbit LED will be flashing. The first time the hardware is plugged into the PC, the USB driver will need to be installed by pointing the wizard to the correct location. The file path for the Device Manager wizard is shown in red. Make sure to adjust the virtual COM port settings under Device Manager for 115K baud, 8, none, and 1. To run the NFC Stack GUI, choose to execute the NFC player from Programs in the PC Start menu. After the GUI opens, press the Configure button to pop up the controller configuration subscreen and type in the COM port number the board enumerates to. Click Save, and this will close the subscreen. Press the Start NFC button if correctly set up, then NFC Start OK will appear in the lower left-hand window of the GUI. Reader or writer modes are demonstrated and explained by showing the tag types and the commonly used record type definitions. For those wishing to use the reader-writer mode, either leave all of the defaults checked or select individual tag technologies and features to use. Then press the Start RW button. RW Start OK will appear in the lower left-hand window of the GUI. When the hardware is in reader-writer mode, LED 1 will be flashing, and then go solid when an NFC RFID tag is presented. LED on pad 3 is solid because one of the NFC mode has been selected. After pressing the RW button, present an NFC tag, formatted or not. In this example, we are presenting an unformatted ISO 15693 TI tag. Note the tab automatically flips to RW Legacy, and the type of card is displayed graphically along with the unique ID. The user can press the Format NDEF button to make the tag NDEF compliant. After the tag is formatted, the GUI status window will quickly flip to Format NDEF OK. Then present the RW NDEF with the status changing to RW Read NDEF OK. The user can now enter data into the bottom right window and press the right button to write NDEF message into the tag. When this occurs, the screen will quickly flip to write NDEF, then the user can either press the read button or remove the tag from the reader-writer antenna and represent the tag to get the NDEF message read back. Below, you can see the NDEF size is now 236 bytes out of 250, and the message is displayed. Here's tag type 2, which has been formatted with the tool and then programmed as an RTD smart poster. If suppress NDEF RTD action in the front panel box is unchecked, presenting this tag will open the browser up and will be routed to ti.com/NFC webpage. Here is tag type 3 from Sony, and also known as Felica, which has been formatted with the tool and then programmed as an RTD URI. Here's tag type 4A, which has been formatted with the tool and then programmed as a V-card or electronic business card. Here's tag type 4B, which has been formatted with the tool and then programmed for an NFC forum Bluetooth connection handover, as used to simplify the pairing process. Here's tag type 4B, which has been formatted with the tool and then programmed with an image. This demonstrates a larger file being stored, which could then be extracted out by another NFC device or via the host over I2C or SPI. To stop the RW mode, remove the tag in the field and then press the stop button. The TRF7970A is capable of emulating a Type A or Type B card at 106 kilobits per second. In the next set of slides, we are showing how this is demonstrated using the host stack and the embedded MCU library together. This NFC mode is being used for a variety of applications where larger tag sizes are needed. In the previous set of slides, we showed the R430CL330H, which is a dynamic tag with 3 kilobytes of memory. Here, we are showing something similar but with 8 kilobytes of space. The size of the emulated card is really limited only by the settings in the system, meaning the card could be indicated to be much larger. For those wishing to use the card emulation mode, under the host-based card emulation, choose the mode, the configuration, and the capability container configuration, and press the Start CE button. When the hardware is in card emulation mode, LED 3 will be solid, and the LED on pad 3 is also solid, indicating one of the NFC modes has been selected. When hardware is in card emulation mode, and an NFC-enabled device acting as reader-writer is presented, LED on pad 1 will illuminate. This is helpful to locate the antenna location of readers. The pad 1 LED will flash as the device approaches, then when field strength is strong enough, it will stay on solid. When an NFC handset or other NFC-enabled reader-writer is presented, the hardware will be read out just like a passive NFC RFID tag. Here we show various screen captures from a handset application called NFC Tag Writer from KDDI, demonstrating the V-card, URI, text, smart poster, and large text RTDs. Here, we show the GUI screen as is showing the packet activity between the NFC handset and the hardware. You can also use a handset application like the KDDI one to write an image, for example, to the hardware. Then, of course, the user can read back the image or other data from the hardware using the application on the handset as well. The user can also set up 2 of the hardware sets and run 2 instances of the GUI on the same PC, with one as a reader-writer and the other in card emulation. Then read-write data without using an NFC handset. Here we have written about 5.7 kilobytes of an image and have read it back. The TRF7970A is capable of being a Type A or Type F peer-to-peer target or initiator at 106 kilobits per second, 212 kilobits per second, or 424 kilobits per second. In the next set of slides, we are showing how this is demonstrated, using the NFC host stack and the embedded MCU library together. This NFC mode is being used for a variety of applications where a data transport system is needed for data exchange, firmware updates, or simplified setup of alternative radios. This differs from card emulation because once the connection is established, data can be passed both ways and multiple channels can also be set up to provide for high-speed data transmission schemes over the magnetic link. Early versions of the NFC devices use NDEF push protocol called NPP. Now the NFC Forum has a newer specification called Simple NDEF Exchange Protocol, or SNEP. Both are supported with the embedded firmware and host stack. For those wishing to use peer-to-peer, under the peer-to-peer column, choose the SNEP box, then press the Start Peer-to-Peer button. Peer-to-peer star OK will appear in the lower left-hand window of the NFC GUI. When the hardware is in peer-to-peer mode, LED 1 and LED 2 will alternate flashing. The LED on pad 3 is solid, because one of the NFC mode has been selected. When an NFC device is presented, the mode which is being used by the hardware, initiator, or target will go solid. After the communication is terminated, the LEDs will go back to alternate flashing. When an NFC-enabled device is presented, the GUI screen flips over to peer-to-peer mode. A message can now be sent from GUI to the NFC-enabled device using the transmit button. This will open either the native app on the phone or a user-downloaded application. When an NFC-enabled device has an application open for doing peer-to-peer, the GUI screen flips over to peer-to-peer mode as before. A message can now be sent from the NFC-enabled device to the GUI. Here, we are beaming a URL to a TI website. Other messages can also be sent. The user can also set up 2 of the hardware sets and run 2 instances of the GUI on the same PC, then demonstrate peer-to-peer functionality without using an NFC handset. Here we have sent an RTD MIME message in the form of an image from one hardware set to another using Snap. In this example, we have sent multiple records including an RTD URI, Smart Poster, vCard from one hardware set to another, also using Snap. It is important to realize here that once the connection and symmetry is established, the device on either side can send something to the other device without changing any settings. The NFC Stack GUI has an advanced peer-to-peer feature where the user can establish a 2-channel bidirectional communication link between 2 kits. This will be useful for firmware updates or large data transfer when the user can set a device down for at least a few seconds. Here we have set up 2 devices, one as target, the other as initiator, and established the communication symmetry. We have chosen the Stallman API tab available and started the listeners. Next step is to do a connect on either side. Then on either side channel, choose Continuous under a Transmit button and depress the Transmit button. This will start a continuous stream of data to begin flowing over the NFC link. This slide shows the amount of data streamed and in what direction it was sent. The NFC Link installer would include the following folders. The doc folder includes the user guide. The driver-lib folder includes the UART, GPIO, and timer drivers. The example folder includes the CCS, reader-writer, peer-to-peer, and card emulation projects. The NFC Link lib folder includes the NFC source and binary files used on the CCS projects. The USB lib 430 folder includes the USB drivers. The utils folders includes the NFC player installer. The following layers will have to be modified when porting to other MSP430s. The host interface layer has the drivers for the interface used to communicate between the host and the controller. The MSP430 hardware layer has the main application, MSP430 mClock initialization, watchdog timer code, GPIOs, and timer driver implementations. The TRF7978 transceiver interface layer has the drivers for the pins connected to the TRF7978. For a detailed description on the functions needed to be modified, please reference to the NFC Link User's Guide included in the doc folder. For further information, please visit ti.com/NFC Link, and thank you for watching.